On July 15th, 2026, a small team of scientists sat down to look at data from the James Webb Space Telescope, and what they found made their hearts skip a beat. They were not looking for anything new. They were simply checking on an old familiar planet they already knew about. But buried inside the numbers was something that should not have been there. A signal, a strange jagged pattern like a barcode hiding in the middle of empty space. And when they finally understood what they were looking at, it hit them like a punch to the gut. There was a giant planet, bigger than Jupiter, sitting right in front of humanity's most powerful telescope. For years, completely unnoticed. Nobody saw it. Not Hubble. Not the giant ground telescopes in Chile. Not even Webb itself at first. It was hiding in plain sight, wrapped inside a glowing cloud of cosmic dust, like a criminal hiding inside a crowd. And it had been fooling astronomers for decades. Today, we are going to walk through exactly how this happened, why NASA missed it for so long, and why this discovery is now being called one of the most important exoplanet stories of the year. Stick with me, because by the end of this video, you will understand why scientists are saying this changes the way we search for hidden worlds across the entire galaxy. Let's go back in time first, because to understand how shocking this is, you need to understand the star system where all of this happened. It's called Beta Pictoris. It sits about 63 light years away from Earth, which sounds impossibly far, but in cosmic terms, it is basically our neighbor. Beta Pictoris is a young star, only around 23 million years old. Now, that might sound ancient to us, but for a star, that is like a newborn baby. Our own sun is 4.5 billion years old, so compared to our sun, Beta Pictoris has barely opened its eyes. Because it is so young, it is still surrounded by a massive disk of dust and gas, the leftover material from its formation. The same kind of material that eventually clumps together to build planets, moons, and asteroids. Scientists have been obsessed with Beta Pictoris since the 1980s, because it gave them a rare front row seat to watch a solar system being built in real time. It's like catching a house under construction instead of only ever seeing the finished building. Back in 2008, astronomers announced something huge. They had directly photographed a planet orbiting Beta Pictoris. This was a massive deal at the time, because most exoplanets, planets outside our solar system, are never actually seen with a camera. They are usually detected indirectly, by watching a star dim slightly as a planet passes in front of it, or by watching a star wobble because a planet's gravity is tugging on it. But this one, called Beta Pictoris b, was actually captured as a real image, a tiny point of light next to its blazing home star. It became one of the most famous exoplanets ever found, a poster child for what direct imaging could do. Then, in 2019, scientists found a second planet in the same system, Beta Pictoris c. 2 giant planets confirmed, sitting inside that swirling disk of dust. Beta Pictoris became one of the most heavily studied planetary systems in the entire Milky Way. Telescopes all over the world, and eventually Webb itself, kept turning back to this system again and again, squeezing every bit of information they could out of it. And here is the part that should make you a little uneasy. For years, scientists assumed they had a full picture of this system. 2 planets, a debris disk, done. Case closed. Except it wasn't. Because hiding inside that same disk, invisible to every telescope pointed at it, was a third giant planet, at least twice the mass of Jupiter, quietly orbiting this star the entire time. Nobody knew it was there. Think about that for a second. This is not some obscure star that nobody has ever looked at. This is one of the most photographed, most analyzed, most obsessively studied star systems in modern astronomy, a system scientists have poured decades of research into, and there was still a giant hidden world nobody had caught. If a planet that big can hide in a system this famous, right under the nose of the best instruments humanity has ever built, it makes you wonder what else might be lurking out there, unseen, in systems we think we already understand completely. So how did it finally get caught? This is where the story gets really interesting, because this wasn't some planned headline-chasing search mission. It happened almost by accident. In the months leading up to the announcement, a team led by a researcher named Aidan Gibbs, working out of the University of California, San Diego, was using Webb's NIR-SPEC instrument, which stands for Near Infrared Spectrograph, to study Beta Pictoris b, the very first planet found in the system back in 2008. They were not hunting for anything new. They were simply trying to learn more about a planet they already knew existed, studying its atmosphere in more detail using a special tool called an integral field unit. This tool is clever because instead of just taking a picture, it captures both an image and a full light spectrum from every single pixel at the same time. Basically, every tiny point in the picture also carries its own fingerprint of information about temperature, chemistry, and motion. While digging through this data, something strange showed up. In a spot where the team expected to see a smooth, boring signal, just starlight bouncing softly off dust, they instead saw a jagged repeating pattern of peaks and dips. Gibbs later described it perfectly. He said they weren't looking for a new planet. They were trying to understand one they already knew existed, and then this telltale signal appeared exactly where they didn't expect it. Imagine spending years studying a familiar photograph, and then one day noticing a shadow in the corner that was never there before, or that you simply never noticed. That is essentially what happened here. At first, the team was cautious, and honestly, they had every reason to be suspicious. Space telescopes sometimes produce fake signals, glitches caused by the instrument itself, or strange structures within the dust cloud that can trick you into thinking you're seeing something that isn't real. One of the scientists on the project, Jean-Baptiste Ruffiot, put it bluntly. He said there was an unexpected bright blob of light sitting in the imaging data, but scientists have learned the hard way not to trust random bright blobs, because they can be nothing more than instrumental artifacts or weird dust structures playing tricks on the eyes. This is the moment where a lot of discoveries in science quietly die. A strange blob shows up, someone gets excited, and then it turns out to be nothing. A glitch, a shadow, a trick of the light. So the team had to dig deeper before they could get excited. And this is where the spectrum data saved the day, because they weren't just looking at a picture, they had a full spectrum attached to that bright spot. They were able to check immediately whether it was real. What they found inside that jagged pattern was a very specific and very recognizable chemical signature, carbon monoxide, spread out like a barcode across the data. This exact kind of pattern is a known signature that shows up in the atmospheres of giant planets. It wasn't random noise. It wasn't a glitch. It was a chemical fingerprint, and fingerprints do not lie. But even that wasn't enough proof on its own, because there was still a chance this signal was coming from something else entirely. Maybe a faint background star sitting far behind Beta Pictoris, just happening to line up in the same direction. Or a brown dwarf, which is sort of a failed star that also carries carbon monoxide in its atmosphere. So the team pushed further. Because they had a spectrum, they were also able to extract something called radial velocity, which basically tells you how fast an object is moving toward or away from you. Using that, they worked out this object's speed, its position, and its alignment with the debris disk around Beta Pictoris. Every single measurement lined up. The speed matched. The position matched. The alignment matched perfectly with something orbiting Beta Pictoris itself, not some random background object, and definitely not an instrument glitch. This thing was real. This thing belonged to the system. Once the team believed they had found something genuine, they didn't stop there. Because in science, one piece of evidence is never enough when you're making a claim this big. They went back to Webb and used a completely different instrument called MIRI, which stands for Mid-Infrared Instrument, through what's known as a Director's Discretionary Time Request, essentially an emergency request, to use the telescope outside the normal schedule because the discovery was considered urgent and important. Using MIRI, they found even more evidence, detecting water vapor and methane in the planet's atmosphere. 2 separate instruments, 2 separate methods, both pointing to the exact same conclusion. And, as if that wasn't enough confirmation, a completely separate research group led by Ben Sutcliffe from the University of Edinburgh and Marcus Bonts from the European Southern Observatory ran their own independent study using ground-based telescopes at the European Southern Observatory's Very Large Telescope, combined with Webb's NIR-CAM camera, and they confirmed the exact same planet, completely independently. When multiple teams, using multiple instruments, multiple methods, and multiple locations, all land on the same answer, that is about as solid as scientific proof gets. The planet was officially named Beta Pictoris d, and here's what we now know about it. It is estimated to be at least twice the mass of Jupiter, which, for context, Jupiter itself is already more massive than every other planet in our solar system combined. So this new planet is a genuine giant, easily one of the biggest objects in that entire star system, and yet it still managed to stay hidden. Its orbit sits at roughly 30 astronomical units from its star. 1 astronomical unit is the distance between Earth and the Sun, so 30 astronomical units puts this planet at a distance roughly similar to where Neptune sits in our own solar system, way out on the edge in the cold, dim outer reaches. Out of the 3 known planets in the Beta Pictoris system, this new one has the widest orbit of them all, though it still sits just inside the inner edge of that huge, dusty disk surrounding the star. Now let's talk about why this planet managed to stay invisible for so long, because this is honestly the most fascinating part of the whole story. Beta Pictoris is famous for having one of the brightest, densest debris disks ever discovered. Picture a swirling, glowing cloud of dust and gas wrapped around the star like a giant halo. For years, scientists have described this disk almost like fog. It scatters light from the star in every direction, creating a bright, messy background that makes it incredibly difficult to pick out a small, dim object hiding inside it. Traditional planet hunting methods rely on spotting a tiny point of light against a dark background, similar to trying to spot a single firefly in a dark field. But now imagine trying to spot that same firefly, except the entire field is filled with fog and lit up by floodlights. That is essentially the challenge Beta Pictoris presented. The dust didn't just make it hard to see the planet, it actively camouflaged it, scattering enough light to bury a giant planet's faint glow inside the noise. This is exactly why the old method of searching for a bright dot in an image completely failed here for years. But the new method, using spectroscopy, doesn't care about the fog at all. Instead of trying to spot a point of light, it looks for a chemical signature, a specific pattern of light absorption caused by molecules like carbon monoxide, water vapor, and methane. These chemical signatures are incredibly specific and don't get lost in scattered starlight the same way a simple point of light does. It's the difference between trying to find a person by sight in a crowded, foggy stadium versus using a device that can detect their unique scent from anywhere in the building. The fog stops mattering. Beta Pictoris D wasn't caught because someone finally saw it. It was caught because someone finally smelled it, in a manner of speaking, through its atmospheric chemistry. Here's something that makes this whole discovery even more remarkable. Scientists had actually predicted something like this might exist long before they ever confirmed it. For years, researchers studying the debris disk around Beta Pictoris noticed it had a strangely sharp, well-defined inner edge, almost like something invisible was carving out a clean boundary in the dust. In astronomy, when you see a debris disk with an oddly sharp edge like that, it's often a telltale sign that a hidden planet is out there, using its gravity to sweep the area clean, like a plow pushing snow into a neat pile. Astronomers had been theorizing for years that a planet like this had to be lurking somewhere in that gap, shaping the disk from behind the scenes, silently, invisibly. Now, with Beta Pictoris D finally confirmed, that old mystery finally has an answer. The predicted planet was real all along. It just took an entirely new detection method to finally drag it out of hiding. Let's slow down for a second and really sit with how big of a deal this is for the future of space exploration. This isn't just about one planet around one star 63 light years away. This is about a completely new technique that astronomers can now use to hunt for hidden worlds everywhere. NASA has openly said that Beta Pictoris D is the first directly imaged planet ever discovered primarily through moderate resolution spectroscopy, rather than through traditional coronagraphic imaging, which is the older method of blocking out a star's glare to try to spot a faint planet nearby. This new approach means scientists no longer have to rely purely on catching a visible dot of light. They can hunt for chemical fingerprints instead, which opens the door to finding planets in messy, dusty, complicated environments that would have been considered basically impossible to search before. Environments just like the one that hid this planet for years. Astronomers are now saying this method could reveal countless more hidden worlds. Planets tucked inside bright disks, planets buried in dusty regions, planets that have been sitting right in front of our telescopes this entire time, silently waiting to be noticed. And this isn't some isolated one-off event either. If you zoom out and look at what Webb has been finding recently, you start to notice a pattern, and honestly, it's a little unsettling. Just months before the Beta Pictoris discovery, NASA announced that Webb had found strong evidence of a giant planet orbiting Alpha Centauri A, which is part of the closest star system to our own sun, only about 4 light years away. Alpha Centauri has been studied intensely for generations because it's basically our closest cosmic neighbor, and scientists have been desperately searching it for planets for decades. And yet, evidence of a massive gas giant sitting inside the habitable zone of a sun-like star was only recently uncovered there too. If confirmed, that planet would be the closest world ever found, orbiting inside the habitable zone of a sun-like star. Not our own solar system's habitable zone, a different star's habitable zone, right next door to us in cosmic terms. And on top of that, Webb also found something called TOI 199b, an unusual gas giant sitting more than 330 light-years away, roughly the size of Saturn, but with a genuinely strange twist. Its temperature is surprisingly close to Earth's, and its atmosphere is packed with methane, something scientists don't normally expect to see in a giant planet like this. It's one of the first temperate gas giants ever studied in this kind of detail. Do you see the pattern forming here? Over and over again. In star systems, humanity has studied for years, sometimes decades. Webb keeps uncovering planets that were sitting there the entire time, completely unnoticed. Not new planets that just formed. Not planets that suddenly appeared. Planets that were already there, hiding, waiting for the right tool and the right moment to finally be seen. And if this keeps happening in the systems we know best, the ones astronomers have studied obsessively for years, it raises an uncomfortable question. What else is out there that we've simply missed? What is hiding closer to home than we think? That question becomes even more interesting when you think about our own solar system. For years, some scientists have debated the existence of something they call Planet 9, a hypothetical massive planet that might be lurking way out in the freezing darkness beyond Neptune and Pluto, way too far and too dim for any current telescope to easily photograph directly. The evidence for Planet 9 mostly comes from strange clustered orbits of small icy objects way out past Neptune, orbits that seem to be gently nudged by the gravity of something big and hidden, something we've never actually seen with our own eyes. Sound familiar? It's basically the exact same kind of situation that led scientists to suspect a hidden planet inside the Beta Pictoris disk, strange gravitational fingerprints with no direct visual confirmation for years. Now that scientists have proven a new spectroscopic method can successfully drag a hidden giant planet out of hiding in a distant, dusty star system 63 light-years away. It raises a fascinating possibility. Could similar techniques eventually help confirm or rule out something hidden in the far outer reaches of our own solar system? Nobody knows yet, but it's the kind of question that keeps astronomers up at night, in the best possible way. Let's go back to the human side of this discovery for a moment, because I think it's easy to get lost in all the technical details and forget just how emotional a moment like this actually is for the people involved. Picture the scientists sitting there, staring at data for a planet they already understood, a planet that had been photographed, studied, and written about in scientific papers for over 15 years. Then, out of nowhere, a strange signal shows up where it absolutely should not be. At first there's doubt. Is this real? Is this a glitch? Is this some weird trick caused by dust or a faulty pixel? That uncertainty must have been agonizing. Then, slowly, piece by piece, the evidence starts stacking up. The chemical fingerprint matches a real planetary atmosphere. The speed and position line up perfectly with an object orbiting the star. A second instrument confirms it. A completely separate team, working independently with different telescopes, arrives at the same answer. And suddenly, what started as a strange little anomaly in the data becomes one of the most exciting exoplanet discoveries of the year. Aidan Gibbs, the lead researcher, said it best, calling this discovery another fascinating piece of a story that Beta Pictoris has been telling scientists for decades about how planetary systems form and evolve over time. It's not just a new dot on a map. It's another chapter in a story astronomers have been trying to read for years. Now, let's talk about what makes this atmosphere of Beta Pictoris d so interesting, because the chemistry itself tells a story too. Scientists detected carbon monoxide first, and later confirmed water vapor and methane using the MIRI instrument. These aren't just random molecules floating around for no reason. Carbon monoxide, water vapor, and methane are exactly the kinds of molecules scientists expect to find in the thick, swirling atmospheres of young, massive gas giant planets, similar in some ways to what we see in Jupiter's own atmosphere, but shaped by the unique heat and chemistry of its environment. Because Beta Pictoris is such a young star system still actively forming, this newly found planet gives scientists a rare, almost real-time window into what a giant planet's atmosphere looks like relatively early in its life, shortly after formation on a cosmic timescale. It's a bit like being handed a baby photo of a planet instead of only ever seeing a picture of it as a fully grown adult. There's another layer to this story that deserves attention too, and it's honestly a little humbling if you think about it long enough. Beta Pictoris b, the very first planet found in this system back in 2008, was one of the earliest exoplanets ever directly photographed by any telescope on Earth or in space. It became a landmark discovery, something referenced constantly in exoplanet research for years afterward. And yet, even with that level of fame, even with instrument after instrument turning back toward this exact star system again and again for over a decade, a second massive planet, arguably just as significant, remained completely hidden the entire time. This tells us something important about the limits of even our best technology. Just because a system has been intensely studied doesn't mean it's been fully understood. Just because we've looked doesn't mean we've truly seen everything there is to see. Beta Pictoris now joins an extremely short and exclusive list, becoming only the second known planetary system, with at least 3 image planets confirmed around it. That alone puts it in incredibly rare company among the thousands of star systems astronomers have studied. So what happens next? The scientists behind this discovery aren't finished. They've said they plan to continue digging through Webb's observations to nail down even more details about Beta Pictoris d, including a more precise measurement of its temperature, a deeper understanding of its full atmospheric composition, and a more exact picture of its orbit around the star. Every new piece of information adds another layer to one of the best-known planetary systems in the galaxy, a system that, despite being studied intensely since the 1980s, just proved it still has secrets left to give up. And beyond Beta Pictoris itself, astronomers are already looking ahead, wondering how many other dusty, complicated, heavily studied star systems out there might be hiding similar giants, planets that traditional imaging simply couldn't catch, but that this new chemical fingerprint method finally could. If you step back and think about the scale of what just happened here, it really is kind of staggering. Humanity spent decades photographing, analyzing, and obsessing over one particular star system, convinced we understood it fairly well. 2 planets, a debris disk, a well-documented story. And this entire time, a giant planet more than twice the mass of Jupiter was quietly orbiting inside that very system, wrapped in cosmic dust, completely undetected, hiding in plain sight from every telescope that had ever turned toward it. It took a brand new detection method, an accidental discovery while studying something else entirely, and multiple independent confirmations before anyone finally proved it was real. And now that this technique has been proven to work, scientists believe it could unlock a whole new wave of hidden discoveries across the galaxy. Planets buried inside bright, dusty disks that have been quietly fooling astronomers for years, simply because nobody had the right tool to look past the fog. So here's the real question this discovery leaves us with. If a planet this massive could hide for years inside one of the most famous, most studied star systems in the entire galaxy, right under the noses of some of the best telescopes and scientists on Earth, and what else is out there that we simply haven't caught yet? How many other systems that we think we fully understand are secretly hiding something huge, just waiting for the right instrument, the right moment, and the right accidental glance to finally reveal the truth? Space has a way of humbling us like that, reminding us that no matter how advanced our technology gets, the universe is still very good at keeping secrets. Beta Pictoris D spent years hiding in plain sight, and it only took one unexpected signal, buried inside a routine observation, to finally bring it into the light. If this story blew your mind the way it blew mine while researching it, let me know in the comments what you think might be hiding out there next. And make sure you're subscribed, because space keeps proving that some of the biggest discoveries are still hiding right in front of us, waiting to be found.